It seems only natural that music theorists would seek a scientific approach. After all, science is a systematic way of seeking the truth, and what music researcher wouldn't want to discover the truth? But how do we discover this truth? In science, we look for a logical description of cause and effect, and a description that predicts future events. Since music is a human artifact and not a product of nature, techniques from the hard sciences don't do us a lot of good when looking for a description. Techniques from the social sciences, the soft sciences, should be more effective. Of these techniques, probably the most powerful is statistical analysis. We've already discussed simple statistics in earlier episodes, but we have not discussed what those statistics mean. For example, we could do a statistical study of Bach chorales in order to determine norms for Bach's harmonic practice. If these norms match those of functional harmony, that would mean that the statistics show that Bach's harmonies are functional. I did a computer analysis of 69 Bach chorales, and I found that the root movement was by descending perfect fifth or its inversion 37% of the time. Great, we have the answer, but what does it mean? This kind of root movement is the defining root movement of functional harmony. This kind of root movement cannot be a norm in Bach chorales since it only happens 1/3 of the time. Case closed, Bach chorales aren't functional. Not so fast. What about all the other possibilities? You might guess that there's some other kind of root movement that happens more than 37% of the time, but unless you run the statistics for the other kinds of root movement, you'll never know. My analysis was inconclusive because I didn't consider what the number actually meant. If the number was very high, say 90%, then this kind of root movement is a norm. If the number was very low, say 2%, then it can't be a norm. But the number was 37%. That's close enough to the middle that I don't really know what that number means. So I ran the analysis again. I wrote a new computer program that kept statistics for all root movement by all intervals, or rather, by all descending intervals and their inversions. Here are the results for the 69 Bach chorales. It turns out that root movement by descending fifth is the most common kind. It comes in at 35.9%. This is slightly off from the 37% of the previous study, but close enough to be believable. If we remove unisons from the mix, root movement by fifths jumps to 42.1%. I had considered adding descending fourths in with descending fifths. If I did so, it would bump descending fifths up to 58.2%. But are thirds and sixths really different? They are in fact just inversions of the same pitches. The same is true of seconds and sevenths, so I tried combining them. I decided to keep fourths separate for my final version of the statistical chart. To me, a descending fourth doesn't sound or function like a descending fifth. It's like cadences. Plagal and authentic cadences sound different. Our statistics now show that Bach had a preference for root movement by fifth, but not by an overwhelming margin. Fifths beat out the next highest category, seconds and sevenths, 42% to 29%. While this vindicates fifths as the primary root movement, it causes a bit of a problem for theories based on Rameau, since Rameau downplayed root movement by seconds. My study still proved to be somewhat inconclusive. Even though fifths are the most common root movement, they occur less than 50% of the time, so maybe they're not really a norm. If we want to find norms over a larger corpus of material, it's good to check the results of other studies. The first study that I looked at is by David Huron, and it's documented in his book, Sweet Anticipation. The chart lists the prevalence of root movement in two-chord patterns in Baroque music. Statistics in this chart show that root movement by descending perfect fifth is the most prevalent progression for 3 of the 7 diatonic chords. 2 goes to 5, 56% of the time. 3 goes to 6, 38% of the time. 5 goes to 1, 79% of the time. Functional harmony does allow certain substitutions. For example, 4 can substitute for 2 and 7 diminished for 5. In the case of the subdominant, its most prevalent progression is to 5, which it does 38% of the time. 7 diminished serves as a substitute for 5 58% of the time. Tonic chords move to any other chord, so we don't really care where they go. This leaves only the sixth chord defying the norms of American functional harmony. The submedian's prevalent progression is to 5, 28% of the time, rather than to its normal progression in functional harmony, the 2, to which it progresses 23% of the time. Many of the prevalent progressions are weak, by which I mean that they occur less than 50% of the time. The 3 progressions that occur above 50% are 2 to 5 at 56%, 5 to 1 at 79%, and 7 diminished to 1 at 58%. This should not be surprising. Most music theory teachers would probably agree that 5 to 1 is the most important progression in common practice music. 7 diminished to 1 is also important as a leading tone cadence. 2 to 5 is important as a part of a 2-5-1 cadence formula. My experience teaching music theory tells me that the other chords do lots of different things, but when it comes to cadences in common practice music, the chords listed above pull the music into focus. A second study by David Temperley is based on musical examples from the Stefan Koska-Dorothy Payne workbook for tonal harmony. This study is particularly valuable because it's based on a select group of excerpts specifically selected to illustrate the principles of American functional harmony. Temperley's numbers are, for the most part, similar to those found in the Huron book. A few statistics that aren't similar, highlighted in the red boxes, include 7 diminished to 1, which is at 81% in the Temperley, and 58% in the Huron. Temperley has 6 going to 2 at 65%. Temperley's prevalent progression for 6 to 2 does descend by perfect fifth, and it's the one that's supposed to be typical of functional harmony. I think this discrepancy makes sense, because the Temperley chart is based on a music theory book. Its examples should be cherry-picked to demonstrate functional harmony. 4 going to 5 is much less prevalent in the Temperley. This is a bit of a surprise, since this is a standard functional progression. Temperley's most prevalent progression for 4 is 4 to 1 at 47%. This is a little puzzling, but again probably reflects the fact that music theory books contain short, incomplete examples. Temperley includes chromatic chords, and there's some ambiguity as to what these chords are. For example, he includes flat 2 chords, highlighted by green boxes. I would expect a flat 2 chord to be a Neapolitan, which should normally resolve to a 5. Temperley has it resolving to a 5 only 13% of the time. Temperley's prevalent resolution is to a 2 at 53%. This statistic leads me to believe that the chord in question is not a Neapolitan, but is a 7 diminished of 2. Amongst the 3 studies, a norm begins to emerge. The dominant tonic relationship is overwhelmingly important. I suspect that this has something to do with cadences. I wrote a new computer program to test this idea. I went back to the 69 Bach chorales I looked at earlier and had the computer identify and tabulate cadences. While only 38% of the cadences were actually 5 to 1, another 17% were half cadences by descending fifth, and 12% were cadences using secondary dominants. It could be argued that all of these cadences are of the same kind, only in different keys. 2 categories, 7 to 3 in minor and 1 to 4, could also be labeled as authentic cadences outside the main key. If we include all of those types, authentic cadences make up 70% of all the cadences in the chorales. Final cadences should present the strongest indication of closure, and therefore be the most tonic defining. Of the 69 chorales, 67 ended with 5 to 1 authentic cadences. That's 97% of all the chorales. Earlier, we were looking for definitive statistics. I think we have them. What the statistics tell us is the dominant to tonic root movement is the defining movement for cadences in this repertory. It plays a very strong role in defining tonic and an even stronger role in eliciting closure. We might be tempted to conclude that the dominant tonic relationship is universal to all music everywhere, and that root movement by descending perfect fifth is a natural phenomenon. In the last 2 videos, I looked at studies of shape note hymns and Beatles songs. It might be a good idea to look at the results of those studies in order to test the universality of the dominant tonic relationship. Our shape note study was rather small for a corpus study. Only 8 hymns were examined. This is because the study was conducted with the students in my analysis class, and I only had 8 students in the class that year. In any case, here's a chart showing statistics for the root movement by different descending intervals. Root movement by descending perfect fifth occurred 29% of the time. This is lower than the 37% I found in my first study of the Bach chorales, and still lower than the 42% from the second study. So, while descending fifths are still the most prevalent root movement, seconds and sevenths come in only 2 points lower at 27%, and thirds and sixths a few points lower still at 23%. My conclusion from these statistics is that the shape note hymns are not dominated by any type of root movement, but are instead a mixture of almost equally prevalent types. The Beatles study showed a different result. After all of the calculating was done, root movement by descending fifth came in at 37%, just like the Bach chorale study. This is a little surprising, since Beatles songs and rock and roll in general don't really sound much like Bach chorales. Trevor DeClercq and David Temperley did a corpus study of rock music, and their study might give us more definitive results. Let's compare the charts that show root movement from the rock and roll study with Temperley's study of common practice examples from the Cascapane workbook. A few numbers jump off the page. In the Cascapane workbook, 5 goes to 1 84% of the time, while in the rock and roll study, 5 only goes to 1 53% of the time. This is matched in rock and roll by subtonic going to 1 53% of the time. In the common practice chart, subtonic goes to 1 0% of the time. So in rock and roll, subtonic goes to tonic as often as dominant does. Look at subdominant in the rock and roll chart. It goes to tonic 56% of the time. So it's more prevalent going to tonic than 5 is. A puzzling statistic occurs with flat 2 to 1. It goes to 1 69% of the time. This is a kind of Phrygian progression. This might lead us to believe that the majority of rock songs are in Phrygian, assuming flat 2 is a major chord. A different chart found in DeClercq and Temperley's article shows what the 69% statistic means. This chart shows how many times out of the thousands of chords in the study a particular type of chord occurs. Out of all the chords, flat 2 occurs only 46 times. Flat 2 is only 0.5% of all the chords in the study. The chord's just not that common. This chart clears up a few other things as well. The most common chord after tonic is subdominant, followed by 5, followed by flat 7. So in rock and roll, flat 7 is very important, while the leading tone chord is the least common diatonic chord at 0.4%. So rock and roll is a heavy emphasis on 4 and flat 7, and little emphasis on the leading tone chord. Because of this, rock tends to have a modal sound. DeClercq and Temperley don't supply statistics for cadence types. Instead, they list 3 chord trigrams that often appear as cadence formulas. The chart appears to show that the standard common practice cadence formula 4-5-1 is the most common, but 4-5-1 falls to second place if chord substitutions are allowed. Together, 4-5-1 and 2-5-1 happen 415 times. 5-4-1 and flat 7-4-1 and 6-4-1 happen 564 times, meaning that the subdominant tonic relationship is actually the most common in rock and roll. So what does this all mean? It means that while the 5-to-1 relationship dominates common practice music, it's not universal, because rock and roll is based on 4-to-1. It also means that 5-to-1 is probably not based on some kind of natural law, but is instead a human stylistic preference. It's not nature, it's nurture. This mucking about with statistics may seem like a lot of trouble just to tell us something that many of us already knew. Still, it's valuable because it gives us actual data about a variety of actual pieces. We tend to make pronouncements about how music works without the data to back them up. Statistics gives us that data if we interpret them correctly.